Today we're doing the absolute value inequality. So like I said, okay, we need the two cases, okay, when you're solving the inequalities. So yesterday we did equations, today we're doing the inequalities. So we are going to rewrite these as a compound inequality. Okay, we're going to investigate how we can write them as a compound inequality. And then we're going to organize our findings in the chart that's at the top of the next page. Okay? So when you have inequalities, you're either going to have the AX plus B form is less than C. That's one of the inequalities you can have. You can have the less than case, or you can have the greater than case. Okay, so the first thing we're going to do is investigate this less than case. So based on what we know from yesterday, when we were doing the two cases, we always took what was inside the absolute value, okay, and we were able to set that equal to this value. Here it would be less than that value. This would be your case 1. Okay, now for case 2, because we were using an equal sign yesterday, we were able to do the opposite of your C value, but that's because we had an equal sign, so it was fine to just move that over. When you have inequalities, if you're moving over something that's negative, what do you have to remember to do? Switch the sign. So really, what's happening is, whatever's inside here, it could be positive or it could be negative. So case 2 would be that whatever is inside here, we have the opposite. Okay, so if we want to know what happens in case 2, we have to apply the negative to whatever's inside the absolute value. And then we're just going to solve this by dividing by -1. And then like you guys told me, when you divide by a negative, that's going to flip the sign. Okay, so the compound inequality for this consists of what we have for case 1 and what we have for case 2. Now, a compound inequality, it can be an AND situation or an OR situation, okay? An AND means that they happen at the same time. An OR means they're two different cases, so they don't have to satisfy one inequality. That'll make more sense once we start talking about numbers. Okay, so for example, let's just say C in this case is 5, okay? If C is 5, this is saying that a value is less than 5 and also greater than -5. Can we think of some numbers that are less than -5 and also greater than 5 at the same time? Yes, okay, so this is an AND situation. This is how we connect it. We write the AX plus B in the middle, and then see how the greater than, did you guys learn this with the alligators? They eat the bigger number, right? Okay, so this is greater than -C. At the same time, it is less than C. This is the compound inequality for your AND situation. Okay, so yeah, we can have numbers that are less than the positive value and also greater than the negative value. Okay, so this is something we're going to organize in our chart. Okay? Now, if we have the greater than, for case 1, we have AX plus B is greater than C. Okay, and then our case 2, we are going to apply the negative just like we did before. Okay, so in case 1, this just is what it is. We aren't doing any solving right now. We're just trying to get the AXB by itself. And then we're going to divide by -1. which of course is going to flip your sign. Okay, now here they're saying that this value is less than negative c and greater than c. So if we think about this, okay, again we can use 5 as an example. Is there a number that's less than negative 5 and at the same time is greater than 5? I can't think of any either. Okay, so this is going to be connected with an or. There's no numbers that are less than negative 5 and at the same time are greater than 5. So we connect this with an or, and then usually what we will do is we'll write the less than first. So ax plus b is less than negative c, or ax plus b is greater than c. Okay, so these are going to be, this is our situation for if you start with the greater than. This is the greater than case. This is the less than case. Okay, so we're going to organize that into a table so that you can easily refer to that when you are doing your practice problems, okay? Alright, so let's flip it over. So we're organizing our findings in this table. So this is the absolute value inequality, okay? So we can do the absolute value of ax plus b is less than c. Okay, and then the same thing would happen if you had the less than equal to. Okay, both of those are going to be in the same box. Okay, so whether you start with a less than or less than equal to, okay, they are both going to lead to a compound inequality. So for the first case, it would be the opposite of c is less than ax plus b, which is less than c. This is the same, the only difference is you have the equal to with it. Okay, so if you have less than, you're going to have one big compound inequality. Okay, and then you can also have the greater than. Okay, so for the greater than, you have ax plus b is greater than c, or ax plus b is greater than or equal to c. Okay, so that's what you start with. You have the greater than, or the greater than equal to. Okay? Alright, so if it is greater than, then you have the ax plus b is greater than c, or ax plus b is greater than the opposite of c. And then this one's the same, you just have the equal to. This should be flipped, sorry. Yeah, this sign, so we just check yours here. This will just be the zip. So remember, it flips because when you're dividing by that negative here, okay, the sign is going to flip. So in order to get this case, we had to divide by the negative. That's why the sign's going to flip. Okay? Alright, so now we're going to solve the inequalities, and then you are going to graph the solution set on a number line. So don't forget that. I think as I was checking some homework from yesterday, some of you forgot to do your number lines or your graphs, okay? So make sure you're reading those directions carefully. Now, just like we did yesterday, the first thing you want to do is isolate the absolute value. Okay, so how am I going to get this absolute value by itself here? Yep, subtract the 2. So then I have the absolute value of 2m plus 5 is less than or equal to 7. Okay, and then I'm just going to use my table to write the compound inequality. So once you do that, you're going to write the compound inequality. I'm just going to abbreviate that. Okay, so if I'm looking at my chart, this is the less than equal to. So I have this case here, and that means I can write this as negative c is less than or equal to ax plus b, less than or equal to c. Okay, so in this case, our c is 7. So we're always going to start with what's inside the absolute value in the middle. Greater than 7, or sorry, less than 7 and greater than or equal to negative 7. So notice this part is the same. Okay, you just have to tack that negative 7 on there, and then we're going to solve. Do you guys remember how to solve a compound inequality? You just have to, like if you had this, what would you do to both sides? Subtract 5. So now you just do the same thing, but you're doing it twice. You're doing it on the right side and on the left side. Okay? So negative 12 is less than or equal to 2m, which is less than or equal to 2. Okay, and then from there, we're just going to divide each side by 2. So negative 6 is less than or equal to n, which is less than or equal to 1. When you get here, you do want to ask yourself if this is possible, because sometimes you can have no solution. Can we have a value m that is less than or equal to 1 and also greater than or equal to negative 6? Yeah, what are some values? 0 works? Negative 4? Great. Okay, so yes, that's going to be a solution. So now we can do the number line. When you're doing your number lines and you have like these two values, I'm fine if you do negative 6 and then 1 here. Okay? And then if you have the equal to, what does that mean? Closed circles. So closed circles for equal to, open, there's no equal to. Okay? Okay. All right. Do you guys think that you could start B for me? Yeah. Thank you. So I want you to isolate the absolute value and then see if you can find the compound inequality, okay? Okay, Joey, help me out. What did you do first?
Oh shoot. I just ate to both sides.
Yeah. And then
Since it's the opposite for like the compound inequality, like the negative c goes in the back, and it's
Yes.
already a negative, you make it a positive in the back.
Exactly. So once you realize that this is the less than equal to, you are going to use, it's actually the same rule that we did before, so it's the opposite of c. So if you do negative, negative 1, we know that that's going to switch to a positive 1. get to a situation like this, you might notice that this is a little bit strange already. If you go forward and solve, you are going to get some fractions, don't worry. Okay, we're just going to reduce them, so this would be 7/3. This is going to be -8/3. Which number is bigger, -7/3 or -8/3? -7/3 is bigger, right? Because it's closer to 0. Okay. It also might help if you think of it as a decimal. I do want you to leave your answers as fractions, but for this, I'm going to just write the decimals underneath to help you realize what's happening here. Okay. So what this is saying is that x is both less than or equal to -6 and greater than or equal to -2/3. Okay, is there a number that's both greater than -2.3 but less than -2.6? If there is, you could tell me one. That. Okay, so -2.5 would be less than -2.6, but it wouldn't be greater than -2.3.
There's none.
It's not.
There's not, okay? And I know sometimes the decimals are a little bit harder. Let's look at this, right? Is there a number that's going to be less than -1 and at the same time greater than 1?
No.
At the same time? No. So this can't happen at the same time. That's the problem. And this is an and situation, okay? When it can't happen at the same time, your final answer is going to be the no solution with the null set. You can just write this down. When you do get no solution, you don't have to graph. Okay, so you don't have to graph if it's no solution, but if you don't realize at this point that that can't happen at the same time, and you did try to graph this, you have to put the -2.6 here, you have to put the -2.3 here, and x would be greater than or equal to the -2.3 and less than the -2.6. So you can't have these going in opposite directions for the and situation. Okay? So you can't have this if it's one compound inequality. Every compound inequality that has the and will look like this. Okay? You can only have graphs that look like this if you have the or, which is what we're going to investigate next. Okay, so for C, is your absolute value isolated?
Yes.
Yeah, so we can just go right into our compound inequality. Okay, so we're going to find the compound inequality for, this is the greater than. Okay, so if I go up to my chart and I'm finding the compound inequality for my greater than, it leads me to this. Okay, so it's either greater than C or less than the opposite of C. Okay, so for this one, when you're writing the first one, it's just exactly as it looks. It's going to look just like that. The only thing you don't have is the absolute value. Then we have the or. Now this time, when you're doing the opposite of C, this is going to be really similar to what we did yesterday. Remember when you have a quantity and you have a negative, you have to make sure you do what with the negative? What are we going to do with that negative there? Distribute. Yep. So the opposite of C in this case is going to be distributed to both of those. Okay, so now we're going to solve each one for A. So we know this is a half. So write it like that. Okay, so we have 5A here. At the same time, I'll move over the 2. Divide both sides by 5. So A is greater than 2/5. And then I'm going to distribute the negative. So now I'm adding a half to both sides. So I have 6A is less than -6. Divide both sides by what's in front of A. Now, do we have to switch the sign here? No, why not? Because you're not dividing by a negative. When you're dividing by a negative, you look at the bottom. The bottom is positive here, so you aren't switching any signs. It doesn't matter if the top's negative, it only matters if you're dividing by a negative. Okay, so remember, these are connected with an OR. So when you write your solution, okay, you should put the -1 first. That's also what's going to come first on your number line. So A is less than -1, or A is greater than 2/5. You never have to worry about an OR situation being no solution, because if it's OR, they don't happen at the same time. Right? I'll say that one more time. If you have an OR situation, you never have to worry about it being no solution, because they don't have to happen at the same time. Okay, so you don't have to worry about that. So when you go to make your number line, you have -1, you have 2/5. Are these going to be open or closed circles? Open. So it's greater than 2/5 or less than -1. It's okay to have this gap here because of the OR. So we are all set there. Alright, we're going to move on to part D, and I just want you to tell your elbow partner what you're, like in your row, what you're going to do first there. Let's come to a consensus. Alright, were we all in a consensus, or are we divided between two different ways to do this? What are we going to do? Are we going to take care of the 13 or the 4 first? The 13. So when you are solving any equation, anything that's added or subtracted to the end, that is what gets moved over first. Now technically, could you multiply everything by 4? Yes. But when people do that, they forget to distribute the 4, so I don't recommend that. If you did divide by 4 and you distributed, that could also be a viable solution. But I recommend just moving over the 13, and then you can divide by the 4. And be careful with those absolute value signs. Sometimes when you're like writing things out, do you guys think it's a 1? That happened yet?
Oh, yes.
Yeah. Alright, so now we're going to multiply by 4. Now here, 4 divided by 4, those are going to cancel. So you just have the absolute value of 3x minus 12 is greater than, 72. Do you guys know how to do that without your calculator in a quick fashion? Yeah. What would you do?
8 times 4 plus 4.
Yeah, exactly. So do just split, instead of 18, just do 10 and 8. So 10 times 4 is 40, 8 times 4 is 32. That's easy for you to add. You didn't have it. Okay? Alright, so now, is this greater than or less than? Greater than. So let's find our equivalent compound inequality. Okay, so then we'll have 3x minus 12 is greater than 72. Okay, and really, as you practice this, I hope it would feel weird to put this symbol with the negative 72 on that side. And then you flip and do the opposite. Uh-huh.
Oh, yeah, never mind. I was just.
Okay, so we're doing the same steps to each side for this one, but negative 72 plus 12 will be negative 60. And then again, remember, what you're dividing by is positive, so you don't have to switch the sign here. It's an or, so I don't have to worry about this being no solution. Okay? And then really, I want you to write your solution as x is less than negative 20 or x is greater than 28. That also just helps you remember to put it on your number line correctly. Because when you're doing your number line, the negative number has to come first. Okay, and then these are open circles, so you just have the greater than and less than. There you go. Okay, now I do just want to give you a little extra note, because sometimes this happens when you're solving the inequalities, and I don't want you to panic. Let's say you just have like negative x is less than 10 greater than negative 5. So when you divide by a negative, what happens? The sign flips. So this becomes 5, and then you flip, and then you flip. Okay? This is not the way that it should be written. You need to rewrite it. Okay? So rewrite where x is in the middle. So x is less than 5, and it's greater than negative 10. Because see, this is not a wrong statement. X can be greater than negative 10 is less than 5. But you do want the lowest value here, and you want the highest value here. Okay? So if that happens on your homework, okay, you're just going to rewrite it. That doesn't mean there's no solution, okay? Alright, we are going to quickly look at the first 3 columns of your homework from last night.